So today I'm going to talk about how to find the derivatives of exponential functions. First, let's talk about the derivative rule for exponential functions. I've written out the rule just like you'll see on your formula sheet. Remember that it's good to be familiar with this mathematical notation so that if you ever have to go back to the rule, you'll know what it's actually telling you to do. One thing to note here is that the exponential derivative rule is actually two rules, one for the simplest case and one that is basically a chain rule. Let's start with the first rule. The first rule here is just saying that the derivative of e to the x is simply e to the x. We won't focus too much on the mathematics of why this is the case, but remember here that e is a constant, like pi. Even though we're using a symbol to denote this constant, e is not a variable, and so we still only have one variable in this function. Again, the derivative of the simplest case of an exponential function, which is just e to the x, is e to the x. There isn't any change here. Remember that an exponential function is just one that has a base e and an exponent with some sort of variable. So now let's focus on the chain rule for exponential functions, because this is the one that you'll primarily be using. The good news is that it looks very similar to our previous chain rule, which we also called the general power rule. But this rule is telling us that when we have an e with a function in the exponent, to take the derivative, we simply rewrite the original part of the function and then take the derivative of the function that is in the exponent and multiply that on the end. This will be a lot easier to understand with a few examples. In our first example, we see that we have e with x squared plus 4x in the exponent. The steps are the blue numbers. In the first step, we determine the different parts of the function. E is of course the same, but we need to recognize that x squared plus 4x is the same as the f of x in the derivative rule. Our rule says that we need the derivative of this exponent piece, so that will be our second step, taking the derivative of the exponent. Now that we have all the pieces, we can go to the third step, where we rewrite our original function and then multiply it by the derivative that we just found in step 2. This is because we're following the recipe for taking the derivative of exponential functions. If we have a function, not just x in the exponent, we need to take the derivative of this exponent and multiply it on the end of our original function to get the derivative of that original function. So the derivative of e to the x squared plus 4x is e to the x squared plus 4x times 2x plus 4, like you see written in the third step. If we want to, we can rearrange or combine constants at this point, but you don't have to, and in this case we don't have any constants that could be easily combined, so we're just going to leave it as is. In example 2, we see that we now have a constant 2 attached to this exponential function, but remember by the constant multiple rule that we can just carry our constant through to the derivative. It's like a friend that hangs on to the function even when we transform the function into a derivative. So we're going to ignore the 2 and focus on our 3 steps. First, we identify which parts of our rule match with our function and recognize that x cubed minus 3x plus 1 is the same as the f of x in our rule. In step 2, we take the derivative of this exponent, and then in step 3, we put all of the pieces together, making sure we still include the constant multiple 2 that we've carried with us at each step. Again, we could rearrange here, so I've included some of the other answers that would be appropriate. No one answer is absolutely correct, but the more condensed version, version 3, is useful if you have to use the derivative in a bigger application, such as finding the critical values, inflection points, maximums and minimums, etc. So here are the 3 steps written out so you can reference them as you try some of the problems on your own. Pause the video and try these practice problems out for yourself. I've also included 2 challenge problems which require knowledge of the product rule for the first one and partial derivatives for the second one. In a moment, I'll show the answers for all of these questions. So here we have the solution to challenge question number 1. Remember that this made use of both the product rule as well as the chain rule for exponential functions, and we have a couple different ways of combining the different pieces, so each of the different variations is acceptable as an answer. And here we have the solution to challenge question number 2, which makes use of both the exponential chain rule as well as the box method for partial derivatives. So the last thing I want to say here is that if you had any trouble with the challenge questions, make sure to watch the other videos on partial derivatives, basic derivative rules, and complex derivatives. A lot of times, derivative rules will be combined on tests and homeworks so that you can be tested on multiple rules at once. It's important to be able to do some of these more complicated ones because of that. But make sure that you know your basic rules and the exponential chain rule individually before challenging yourself with the more difficult questions. Thanks for watching.